Hello, super scientists! We are Spark and Sparky, your adventure guide, and today we're solving a big mystery. Why is the sky blue?
Okay, have you ever just stopped, looked up at the sky, and thought, wait a minute, why blue? It's one of those questions we've all had, right? Well, the answer is actually super cool, and we're gonna break it all down.
I mean, think about it. We see this big, beautiful blue dome above us almost every single day. But here's where it gets a little weird, a real head scratcher.
Right? The sun is out there blazing away in the middle of a totally black universe. So how on earth does that same sunlight, after traveling through all that darkness, somehow paint our entire sky blue? That is the mystery we are solving today.
To crack this case, we have to start with sunlight itself, because believe it or not, it's been keeping a pretty big secret from all of us. Yep, that bright white light you see, it's kind of an illusion. It's actually a whole team of different colors, all traveling together, all mixed up so that our eyes just see plain old white. That's right. Hidden inside that one beam of light are all the colors of the rainbow. Red, orange, yellow, you name it. It's only when something separates them, like raindrops making a rainbow, that we see them. So if all those colors are hitting the earth, something must be happening on the way down.
And that something brings us to the main event. This is where the real magic happens. It's a spectacular color show put on by our very own atmosphere. This is probably the most important piece of the puzzle, so listen up. The sky above us isn't empty space. It is packed with a thick blanket of air we call the atmosphere. And it's filled with trillions and trillions of tiny, invisible gas molecules. You can't see them, but trust me, they're the key to everything. Okay, a little bit of science here. To get what happens next, you gotta know that each color of light has its own unique personality. We call this its wavelength. Just think of it like this. Some colors, like red, have these long, lazy wavelengths. But other colors, like blue, have really short, energetic, and super bouncy wavelengths.
And this is where those personalities really make a difference. Blue light, with its short, bouncy wave, acts like a tiny pinball. Red light, with its long, lazy wave, is more like a bowling ball. It just wants to plow straight ahead. This difference is everything.
So, when sunlight finally hits our atmosphere, that bouncy blue light starts crashing into all those gas molecules and just ricochets in every direction imaginable. It bounces left, right, up, down, it scatters all over the place. Meanwhile, the lazy red light, it pretty much just cruises right on through. And this whole process has a really cool scientific name. Rayleigh scattering. It's just a fancy term for what we just talked about, that bouncy, short wavelength blue light scattering way more easily than that lazy, long wavelength red light. So when you look up, you're not seeing light directly from the sun. You're seeing blue light that has bounced and scattered all over the place to reach your eyes, painting the whole sky. Okay, so now we know what's happening inside our atmosphere, but what if we left it? Let's take a quick trip and see what this all looks like from the outside. So picture this. You're an astronaut. You're floating around on the International Space Station, way above the atmosphere. The sun is shining just as bright as ever. You look out the window. What color is the sky all around you? It is pitch black. I mean, even with the sun blazing right there, the sky is just a deep, empty block. So how is that even possible? It all comes back to that one key ingredient we talked about. Out in space, there's no atmosphere. There are no gas molecules for the light to bounce off of. And without anything to hit, that bouncy blue light just keeps going in a perfectly straight line. It never scatters, so it can't fill the sky with color. All you see is black. I love this quote. It's such a perfect way to think about it, isn't it? The blue we see isn't part of space. It's part of our home. It's this thin, fragile layer of air that completely changes our view of everything. Now that you get Rayleigh scattering, you basically have a new science superpower. And you can use it to explain other awesome things, like why sunsets are red and orange. Here's how it works. At sunset, the sun is way down low on the horizon. That means its light has to travel through a much thicker slice of the atmosphere to get to you. On that super long journey, pretty much all of that bouncy blue light gets scattered away from our eyes. The only colors that can actually make it all the way through are those lazy, long wavelength reds and oranges. And boom, that's your sunset. All right, you are now an expert on sunlight and our atmosphere's amazing color show. So I think it's time we put that new knowledge to the test. You ready? Okay, here it is. I want you to think really carefully about everything we just covered.
If our planet Earth had absolutely no atmosphere, no gas, no air, nothing, what color would you see if you looked up during the day? Would it be A, white, B, black, or C, orange? Think about it, lock in your answer, and let me know what you think in the comments. I want to see who's got this.
So let's just do a quick recap. First, sunlight is really a mix of all the rainbow's colors. Second, our atmosphere is a professional at scattering that bouncy blue light everywhere. Third, no atmosphere means no scattering, which gives you a black sky. And finally, that blue sky is a very special feature of our planet. So the next time you step outside and you see that incredible blue sky, just take a second. Remember, you're not just looking into empty space. You're watching an amazing physics display happening live. You're seeing the beautiful, colorful blanket that makes our planet, our home, so special.
Thanks for watching. If you liked it, press like and subscribe for more such stories. Stay tuned.